In this video, we'll be going through question 13 from the 2024 HSC Mathematics Extension 2 exam. Part A. The point A has position vector 8i minus 6j plus 5k. The line L has vector equation xi plus yj plus zk equals t into I plus j plus 2k. The point B lies on L and has position vector pi plus pj plus 2pk. Part I. Show that the length of AB squared equals 6p squared minus 24p plus 125. So we're trying to find the length of AB, so we need to find the vector AB. So AB is going to be the position vector of B, which is p, 2p, minus the position vector of A, which is 8, negative 6, 5. Subtracting these, we get p minus 8, p plus 6, and 2p minus 5. So that's our vector AB. Now we want to find the length of that. And we'll take the square of the length straight away. So that's going to be each individual component squared. P plus 6 squared plus 2p minus 5 squared. And so this is a game of just expanding and simplifying. And so we arrive at that result, and that's what we want to prove. Part 2. Hence or otherwise, determine the shortest distance from the point A to the line L. Now this is the equation of line L, and the point B has this position vector. So what I can see is that I obtain this position vector by setting this value of t equal to p. So if I was to draw this up, I have a line. Don't really know what it looks like, but I have some line. It's clear to me that this line passes through the origin, because this is like saying plus 0, 0, 0, and this would be the origin. So the origin lies on this line L. And then what is OB? OB is a vector that sits on this line, and it moves according to the value of p. So it'll travel along this line depending on whatever the value of p is. Now, the question is asking us to find the shortest distance from a point A to the line L. And A is a point off the line. So if I add A in somewhere, let's say over here, what I'm looking for is I'm looking for the shortest distance. Okay, so that would have to be the perpendicular distance. Let's see if we can get it. That looks like the perpendicular line there. So we're looking for a perpendicular distance. But in order to find this perpendicular distance, what I would need to do is I'd need to find the value of p that once I move it, remember this vector is moving according to p, but once I move it, I end up at this point here. So this is I want the value of p, which gives me b landing at that point, because then I'll have the vector BA or AB, and I can just take its length to find the shortest distance. So what I'm trying to do is I'm trying to minimize this particular expression here, because this is an expression for the length squared, and if I can minimize the length squared, then I'm able to minimize the length. So we'll say the following. So to minimize the length of AB, we can minimize the length of AB squared. So we're going to consider this expression as a function. In fact, it's a quadratic, and we're going to try to minimize it. So the length of AB squared is a quadratic in terms of p. And I know that it's a concave up quadratic. So let's say which is concave up. So if I want to minimize this, it would be equivalent to finding the vertex. Now, how do I find the vertex of such a thing? Well, I can just use simple formula, x equals minus b on 2a. Well, probably shouldn't say x, I should say p. The vertex is at p equals minus b on 2a. So that'll be minus negative 24 divided by 2 times 1. Not 1, 2 times 6. So that's equal to 2. So when p is equal to 2, that gives me the vector b, or the vector OB, ending at that point. So this becomes the point P. And then we can say then that this expression is minimized, the square is minimized when P equals 2. So I'm going to sub P equal to 2 into this expression. I'll get 6 times 2 squared minus 24 times 2 plus 125. Putting that into the calculator should give us 101. And so therefore, the length of AB is minimized to give a value of 101. And I suppose it should be units. Okay, and so that's the shortest distance from A to the line L. Part B. A particle is moving in simple harmonic motion described by x double dot equals minus 4 into x plus 1. When the particle passes through the origin, the speed of the particle is 4 meters per second. What distance does the particle travel during a full period of its motion? Okay, so we're given that x double dot equals minus 4 into x plus 1. And that gives me 2 bits of information. It tells me that n is equal to 2. And tells me that c, the center of motion, is at negative 1. Now, there's a formula for simple harmonic motion that relates a few of the important quantities together, which is v squared equals n squared into a squared minus x minus c squared. So this relates the velocity with the displacement, but it also includes within it the amplitude and n, which is the frequency. Now, what do we know? We know that n is equal to 2, so we've got v squared equals 4 into a squared minus x minus negative 1, which is x plus 1 squared. And let's see, what are we looking for? We're looking for the distance the particle travels during a full period of motion. But we were also told that when the particle passes through the origin, that is, when x is equal to 0, it has a speed of 4 meters per second. So I'm going to sub that into this equation. When x is 0, v is equal to 4. And I'll get 16 equals 4 into a squared minus 0 plus 1, which is 1 squared. Dividing by 4 gives 4 equals a squared minus 1. Adding 1 and then square rooting gives a equal to positive root 5 because a is the amplitude, so it's defined to be positive. Okay, so what that tells me then is that I have an amplitude of root 5. Now let's draw up the scenario. We have a center somewhere here, and we want to see how far we travel in a full period. So a full period would be going 1 amplitude, 2 amplitudes, 3 amplitudes, and then 4 amplitudes. So a full period, or the distance traveled in a full period, is going to be 4 times the amplitude, which is 4 root 5 meters. And that's the end of part B. Part C. A particle of unit mass moves horizontally in a straight line. It experiences a resistive force proportional to v squared, where v in meters per second is the speed of the particle, so that the acceleration is given by minus kv squared. Initially, the particle is at the origin and has a velocity of 40 meters per second to the right. After the particle has moved 15 meters to the right, its velocity is 10 meters per second to the right. Show that the velocity is equal to 40 e to the negative kx. Okay, so we're told that the acceleration is equal to minus kv squared, and we're also told that initially it's at the origin with a velocity of 40 meters per second to the right, so that means it's positive 40. Now what we want is we want to show that v is equal to 40e to the minus kx. Now, what we're trying to do is we're trying to relate the variable v with the variable x. So I need to think of the correct way to rewrite the acceleration so that I can involve v and x. And in this case, choosing v dv dx would be the best choice. Okay, you wouldn't want to use d2x on dt squared because that involves the t variable, which is not exactly what we want. We don't want to involve time here. We're trying to link velocity with displacement. So let's separate out our variables. I'm going to divide by v squared and multiply by dx. I'll end up with dv on v equals minus k dx, and then I'll integrate both sides. So I'll get log of v, the absolute value of v, is equal to minus k x plus a constant. Now, whenever I do a mechanics question, it's quite often that I have more than one constant, so I always just label it C1, because it's quite likely that there's going to be a C2, maybe even a C3 later on. Okay, before I work out the value of this C1, I'm actually just going to make v the subject. So I will exponentiate both sides. I'm going to break off that C1 in the power to get e to the C1. Now I'll strip off the absolute value, and I'll get v equals plus or minus e to the C1, e to the minus kx. And this I will now call a. It's some constant, which I will call a. And I'll say where a equals plus or minus e to the C1. Now I'll use my initial condition to work out what a is. So when v is equal to 40, x is equal to 0. So I'll write that in. X equals 0, v equal to 40. We get 40 equals a e to the 0. So a is equal to 40. I'll place that back into my equation. And there is part I done. Now part 2 says to show that k equals ln 4 on 15. So we need to find the value of k here. Now, is there any other information that has been given to us in the question? And the answer is yes. I didn't write it at the beginning, but I know that after the particle has moved 15 meters to the right, its velocity is 10 meters per second. So that means when x equals 15, the velocity is equal to 10. So I'll sub that in to this equation that I just derived. So 10 equals 40e to the minus k times 15. This is a show question, so I'm not going to skip steps. Divide by 40 gives me a quarter. Then I'll take the log of both sides. Minus 15k. I'll divide by minus 15. And then that negative can be brought in as a power inside the logarithm, which reciprocates the fraction. That should be 1 over 15 ln of 4 as required. So that's part 2 done. Now part 3 says, at what time will the particle's velocity be 30 meters per second to the right? Okay. So here it's asking when the velocity is 30, what is time? What is the t variable? So that means I need an equation to relate v and t together. Now going back to our original equation for acceleration equals minus kv squared, if I had replaced the acceleration with dv on dt, then I'd be able to integrate to get v in terms of t, or t in terms of v, something linking the velocity with the time. So that's what I'm going to do. I'm going to say dv on dt equals minus kv squared. I'll separate out the variables. dv on v squared equals minus k dt, and I'll integrate. I'm going to leave it as k just because I don't want to have to write that fraction every time, but I know that eventually I can sub in that value for k. Okay, so integrating this gives me minus 1 on v equals minus kt, and I'm going to use c2 because it's another constant, different to the other constant c1. Now I do have an initial condition. When t is equal to 0, the initial velocity was 40. So when t equals 0, the velocity is 40. So that means c2 is equal to, let's see, minus 1 on 40. Okay, I'm going to move the C2 over as I substitute it back in. So 1 on 40 minus 1 on V equals minus KT. I'm interested in what T is when V is equal to 30. So when V is equal to 30, I've got 1 on 40 minus 1 on 30. Now I'm going to substitute in the value of K. I know that K is equal to ln of 4 on 15. Should be a negative there. Okay, so this is equal to minus 1 on 12. Yes, it's negative 10 on 120, which is minus 1 on 12, equals negative log 4 on 15 times T. And so T is equal to 15 divided by 12 is 5 on 4. So 5 on 4 log 4 seconds. It doesn't ask to any decimal places, so we'll leave it as an exact value. And that's the end of part 3. Part D. It is known that for all positive real numbers xy, x plus y is greater than or equal to 2 root xy. Do not prove this. Show that if a, b, c are positive real numbers with 1 on a plus 1 on b plus 1 on c equal to 1, then a root bc plus b root ac plus c root ab is less than or equal to abc. Okay, so I'm going to write down the condition that they've given us. They've given us that the reciprocals of these numbers add to equal 1. We're also given the AMGM. And what we want to prove is a root BC plus b root AC plus c root AB is going to be less than or equal to ABC. Now, when I look at what I'm trying to prove here, I can notice that there's a square root involved. So that looks like I'm probably going to have to use the AMGM to involve that square root. But the question is, how am I going to do that? What's going to be my x and what's going to be my y? Well, if I just rewrite that left-hand side as the square root of a squared bc plus the square root of b squared ac plus the square root of c squared ab, then we might be able to make a smarter choice for what x and y are going to be. It also looks like we're going to have to apply this inequality 3 times and cycle through variables, which is a very common technique with inequalities. So what I'm going to say is I'm going to have a look at AB plus AC. So I'm going to make sure that I have a copy of A in each one. The reason I want to do that is because that'll give me an a squared underneath my square root when I apply the AMGM. That's going to be equal to 2 root, actually I can put the a at the front, that's 2a root bc. I'm going to do the same thing for b. I'm going to have 2 copies of b appearing. So there's a b there, and there's a b in this term. So this will be 2b root ac, and the same for c. It's going to be 2c root ab. Then I'm going to add these up. So I'll call this equation 1, 2, and 3. Let's add them up. So 1 plus 2 plus 3 tells me that, what do we have? We have 2 copies of AB plus AC plus BC being greater than or equal to 2 copies of A root BC, B root AC, C root AB. Now, of course, I can cancel off those 2's. And I'm pretty close to what I want. I've got this, which is the left-hand side of what I want. Where did we write it? There it is. Now I've just got this as my right-hand side. But the only bit of information I haven't used is this condition that they've given us. However, because I'm familiar with the polynomials topic from Extension 1, and often we're asked to find the sum of the reciprocals of the roots, I know that when I clear off my denominators here and multiply everything on both sides by ABC, we're going to get the sum 2 at a time, which is this, equal to the product. So let's do that here. We'll say but 1 on A plus 1 on B plus 1 on C equals 1. That's going to imply BC plus AC plus AB equals ABC. And so now I can replace this with ABC. And so therefore, and I'm just going to write it in the right order that they want, A times root BC plus B times root AC plus C times root AB is less than or equal to ABC. And that's the end of part D and the end of question 13.